Hi everyone. I'd like to talk about this example. So we're using this table and I'd like to illustrate it with 4 examples coming from section 4.2 to 4.5. So all questions related to probability using various methods that were introduced in this section. So usually you'll be given just the 4 numbers in the middle, the 44, 6, 90, and 816. The first thing you want to do is to find the subtotal. Here I already find them for you, and also the grand total. So the grand total is just the sum of all the 4 numbers in the middle, the true positive, false positive, and true negative. Right? Then here's the 4 questions. So I indicate where each question come from. So section 4.2 is about classic probability or finding the probability using the classic method. Section 4.3 is using addition rule, 4.4 is multiplication rule, and 4.5, the second topic is finding a conditional probability. So now let's go back to the table and look at the first question. So we want to find the probability of selecting someone who got a result that is false positive. So you can see 90 of them got false positive. So that probability is just 90 over 1000, which is 0.09. So that is simple. So this is the classic approach to find the probability, which is the number of event divided by the number of the sample space. Now let's try the second question. So if one of the test subject is randomly selected, find the probability that the subject had a positive test result or does not use drug. So here you want to use the addition rule because we have this or statement. So a total of 130 test subjects had a positive test result. And a total of 950 test subjects does not use drug. And you can see their intersection is the false positive, which is 90 of them. Right. So now let's define the event. So event A is positive test result, event B is subject does not use drug, and their intersection is the false positive. So 134, that's the positive test result. 90, that's the subject that does not use drug, and then the intersection is this 90. So here's using the addition rule to find such probability. So the answer is 0.994. Okay. All right, let's try the third question. So here I break it down into 2 parts. So basically we have 2 of the test subjects are randomly selected. We want to find that they both had false positive results. Part A is the selection is made with replacement. Part B is without replacement. So there's a difference between that. So if it's with replacement, we use the multiplication rule, but the 2 test subjects that are selected is independent. The process is independent. And then without replacement, then the process would be dependent because say you select a first test subject, then after that you have one less test subject left for the entire group here. All right, so let's take a look at that. So define the event this way. So event A is first test subject is false positive. Event B is the second test subject that is false positive. All right, so that's the false positive. So we have 90 of them out of 1000. Right, so when the process is done with replacement, then this is how you find their probability. In this case, these 2 trials are independent. So the first one selected that is false positive, that's 90 over 1000. And then we go to the whole group again and to make this same process. So then the second test subject is false positive, it's still 90 over 1000. The case for the process is done without replacement. then the probability that the first test subject is false positive is still 90 over 1,000. But then for the second test subject to also be false positive, we have 90 minus 1, which is 89 test subjects that are false positive left. And then we have a total of 1,000 minus 1, which is 999 test subjects left for this entire group here. So then you each get different answer. And the second case is for dependent, when the two trials are dependent. Okay. Last one. Find the probability of selecting a subject with a negative test result given that the subject uses drug. So this given condition indicate that you need to use conditional probability. All right. So then let's define the event. So event A is subject uses drug, event B is negative test result, and their intersection is false negative. Right? Here's event A. All the subject that uses drug. And then here is their intersection. Now in this case, we don't really have to worry about the probability for just getting negative result. And because we're using conditional probability, so let me show you why. All right, so here's the formula for the conditional probability. Now if you read the lecture notes, and by the way, this table is also from the lecture note of section 4.5. The probability of B given A is different from the probability of A given B, so just be careful with that. Now the textbook used the probability of B given A as the notation for conditional probability. So that's why I like to define the event this way, so we can apply this probability directly. If you like to write P of A given B, that's fine with me, but then your denominator have to be changed to P of B. All right, so just keep that in mind. All right, so back to this problem. So probability of B given A is the same with the probability of A and B, which is the false negative, over the probability of A. That's the probability of the subject uses drug. All right, so plugging each of these probability, it's 6 over 1,000 over 50 over 1,000, then you get 0.12. Okay, so I hope these examples help you understand all the concepts from section 4.2 to 4.5. All right, that's it.